Alright, so yeah, I just needed to take a short break. Where were we? They'll find, yes. Alright, so you have two options here. You can do as I've done before. You can just say this asterisk, some files, and whatever you want to do. But one other option is that you can use the files task, where you just put in the files that you want, the file template, whatever you want. You can see again, cal, asterisk, fits, and then you get, I'm just going to open gedit because I actually now I'm going to open it over here. I actually like to use that more than Kate. It's just a preference. It's not that gedit is better or worse than, I just better like to do that. Alright, so let's see if I'm in the correct folder. I am. Let's find, let's call files. So I have, of course, when you do files, as you can see, as you can see, we have B1, B2, I1, I2, and 2. You could probably have less. You can do just one photometry file. You can do 10. You can do whatever you have. If you just do files the way I showed you, then you would get all the files in here sorted. So you have B1, B2, B3, I1, and so on, so on, so on. But you'll have all the files. So I have looted out in some of the files. As you can see, I've chosen B1, I1, R2, and V1. And that is because I found that R2 gave me the R2D2. No, gave me the most stars. But that's one option. You can also make this list by yourself. As you can see, it's a simple text fill file where you put in the names of the fits that you want to use. Sorry, I'm just going to turn down the volume. Yep, that's it about that. Now let's just close that. Alright, and minimize it for now. Let's also minimize make this a little bit bigger. Alright, so now we have that, and let's do epar deo find. Deo find. So when you use a files list that I just showed you, you put an @ and then the name of the list. Again, I would recommend you use the default, so it would say whatever name you have put in here plus coordinate and a number, CO and a Q and a number. Output density image, I don't use that. Output sky image, I also don't use that. We could probably do it just for fun. Default, let's call it that. See if it wants to do that, and see what we get. And we have set the data pass like this. We have set define pass. No, we have set define pass. Alright, so define pass here is we need to define the threshold. Now I have set my threshold to 50. You have to experiment a little bit here, but obviously, if you set the threshold higher, if I set it to 500, for example, I would only get the brightest stars in here. So it sort of defines how much difference there should be between the sky and where it say a star is. But 50 seems to be a pretty good number for me. And let's try to run and see what happens. So it's going to ask me again. FWM features and scale units 2.15, yes. Standard deviation of background and counts 20, yes. Threshold in sigma 50, yes. Data value minimum -42, yes. 30,000, yes. And run and run and run and run. Yes. So we got, and of course, if you also have good U data, you'll also get that. So now you can see we have default cal IC blah 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 here. Yeah, that was probably not what I wanted, so we're going to say delete. That's also something you can do. Coordinates. No, wait, let's just delete. Yeah, I did it, but nevertheless, default cal and anything like that. Yes. Alright, let's do EPAR data find. Alright, so that didn't work. Let's call it star map and sky map. Yeah. And say execute. And yes. No, not more. Alright, so now we get a. Let's just try to look at the sky display. Sky map. V1 fits at fits at 2, and let's see what it looks like. So this is apparently the sky. Interesting. Let's look at the star map. I haven't actually checked what these do. So this is where it say the stars are. As you can see, this is sort of where it sort of cut out the star. So in here it has probably said that we had a no, it's done it everywhere. It's where it picked out the stars. You can see there's absolutely almost nothing in here. And if we look at the sky map, you can see this is the sky that we have, and apparently the stars are also there. But yeah, I'm not entirely sure what these maps do. You can look it up in the manual, but yeah. Let's just delete that frame. Yes. Alright. And delete sky map. Bleh. And delete star map. Map. Bleh. So, yes. That's it. Alright, so let me just show you something that I told you before. Let's just say EPAR data find. Delete that, and say execute. And yes. Plop. Now you can see you got a fits Q1 and a Q2, and if I ran it again, you'd get a Q3 and a Q4 and so on and so forth. Yeah. So that's it, basically. So now you have the coordinate files. You can go into EPAR. Let's just take a look at the checklist. But I think we're there yet. You will find it. Data find, yes. Use FOT to get photometry. Yeah, sure. If you have photometry at different many stars and different places and so on and so forth, you can do a aperture plot in order to figure out what the photometry aperture should do. What you want to have is sort of a curve that shows you where you will not get any more value of turning up the aperture. If you set the aperture too low, you'll sort of squeeze in the star and not get the entire light. You will not get the wings, as it's called. If you make it too big, you will get a lot of star plus sky and something else, and that will skew your photometry. But basically, what I've told you, if you have an observation with a point estimate function of 4 or less, then use somewhere between 12 and 15 in aperture size, and then for the sky it's 5 in the size, and then it should start 5 from your aperture, your photometry aperture. So for my example, I have 13, and then my sky starts at 18, and then is 5 wide. Alright, so let's say EPAR FOT. Now, when you do this first time, I didn't mention that, but when you do this first time, you should probably do add all the files that you have in here in files. The reason why it is reduced for my sake is that I found out where were the most stars in my photometry, and then I used that instead. So I did the first round using DeoFind, looked at how many stars did I get in the different setups. I used a little Python script that I'm going to show you in a little bit, and then I did the photometry. So one thing that I have done, and I'm going to show you that in a different directory, but let's open gedit and open, where is it? Find stars. So this is a little Python script that I wrote, and this is not let's now you know I'm going to go to another library because that is more updated. Let's go to M13 2018 and then let's open reference M13, let's open findstars.py. So this is a little Python script that I wrote. So what do you need in order to get that? What you need to run this script? All right. So let's open another file. I think it is. Let's see. Where is it? Where is it? Oh, sorry. Reference. I think it's in here. Yeah, let's open this one and open this one. All right. So this is basically the positional data for all the stars for IC 1613. I could have opened for, let's just open for M16 to be more precise. NGC there and there. No, not that. Sorry, I'm just fooling around a bit. Where did it go? There. Alright. So how did I arrive from this to this? So again, I used my lovely command awk. Let's say history grep awk, and this should be the one. So you can see what I did was that I say again I use this awk command here. So in the previous that I showed you, you had to put a lot of extra commands in here, and you also use the fprint because you needed a format. You don't need a format now. You just need some lines, some rows, columns. Sorry, columns. So what you need is 13 column 13. It's the name. This is this. Now, as you can see, I've changed some things. So when I did this, I got M13, S2, S3, S4, but because it's redundant, I know what it is that I'm dealing with. I've just removed the M13. You can just do that by say H, Control H, replace. They say M13, that, and then just not put anything in here, and replace all. You could do that. And then I have changed this for a very particular setup, because I use a little program called Peli, which is a part of a program or a little piece of code called Lense Tool that I've used for my master thesis, and that I also use now to do some calculations, perhaps try to write an article or two, something like that, never mind. But you'll need that in order to get any further. So, sorry, I was at the right place. Oh, now it's going completely whack. So let's just take one example and say, let's take B1. Now again, I have opened M13. As you can see, this is a globular cluster. There's a lot of noise in here and annoying things that I haven't really figured out how to get rid of yet. But nevertheless, we have a lot of stars in here, and as you can see, this is very crowded. So it's hard to see where the stars are in here, but you can obviously see the stars out here. Let's look at the entire image. And as you can see, this again has WCS coordinates, and that means that I can use my Peli command. So I'm going to say, let's just go bang, go bang, go bang, go to M13, no, sorry, reference, M13, yes. And as far as I remember, I have grab Peli. I should have, yeah, let's just use this one here. So if you get a hold of the Peli command, it goes like this. So I have put this NGC 6205 policy as I got from using awk or AWK command. I've gotten this format here, which is what Peli can read. So the reason I said reference 0 is because these are in absolute coordinates. If they were in relative coordinates, I would have a reference in here, and then how much distance these coordinates had from this reference here. So let's try. I'm going to close these down because we don't need them anymore. And obviously, just to be absolutely sure that you understand this, let's go and get it again. The pause. This is the pause, right? So this is this number here. Let's take, yeah, let's just search for that. So this is NGC 6205. That's what I've used, and it's this file here. So I simply just downloaded this file and then told IRAF, AWK that I need this column here, and this column here. Alright. So that's it for that. So now that we have that in place, we use the Peli command and we get this. So you can see there's a lot of numbers all around, but we don't care, because what we want to do is go to region, say save, and then you can save it. You can see I have these here. I'm not going to override them, but in this case I would have used the B here instead. And when I hit save and I've saved this region here, I go to my editor here, and then I open AppFont, and let's say it was what was it called? It was called oh yeah, it's somewhere else, sorry. Reference M13, let's go down the bottom. So we have, it was the B standard reg. So we get this. So I'm going to take this and delete it, and then I'm going to use the H command, as you can see here, Control H. So I'm going to take a point like this, replace it with nothing. I'm going to take this one here and replace it with a comma. And then I'm going to take, it's not here, but I'm going to take this as well and replace it with nothing. We can do it just for fun's sake. So let's see, point, replace all. So that goes away. Then we say this one and replace it with a comma. And this goes away. And then we take this one and replace it with nothing. And now we have this file here, this part here. And then we delete this part here, and now we have it. This is what we need. I'm just going to say undo all that, and going to close it. Sorry, yeah. Reference. No, it was okay. M13. And when you save it, you can. I save it in DS9. DS9. I saved it as this name here. .standards.reg. And then I just save the new file, this one, as standard. So now I have all I need to run this command here. I have NGC 205 V standard. I have cal M13 V2 Fitsco. Let's put it there. Let's keep it there. I should have the I have the coordinate files. No, not for V. Let's say V1 then, like this. Now it will probably not give me that much because I've edited them, but nevertheless, let's try to run it. So the way you run a Python script is that you say IPython, and then you say the name, find stars, and pylab, and run. And it finds, probably it will only find what I have put it in there. Let's see when it starts. Yeah, so it finds 98 stars. As you can see, I have already changed the names. So when I open, for example, this one, you can see I've changed all the names here. You basically don't need to do this. This step here, you actually don't need to do yet. But I do find it to be very reasonable to do, because there's no point in doing a lot of photometry on stars that are not present in your catalog. So in this particular script, you can see. Let's open it again. No, let's just open. This is going to be a different target, but nevertheless, I think you can get where I'm going. So let's open V1. Yeah. So you can see you have IDs out here, numbers. You don't have a lot of them like here, but you have IDs. Yeah. You know what? No. Wait a second. Let's do it. Let's just check this. I see. So we're going to do a complete catalog like this. So we're going to minimize this for a second and open. Oh, sorry. Reference IC16, and let's just open V1, for example. Yes. And then we're going to open the Peli command. I'm going to use IC1613. Let's just check it has WCS. Enter. Yes. Now we get that. Then we say region, save region, and make sure we are in the correct spot. We are. We're going to call that IC 1613 slash v slash dot stds dot reg, and check it again. Yes, and it is v. Yes, it is v. And now we're going to set, I didn't say that before, but we're going to set the image, not WCS, because IRAF again cannot read WCS. So you would have, when you try to read in the coordinate systems, you cannot get it, and also the Python script will not be able to read what you give it. It'll just say, huh, what? And then you're going to set it, the DS9 is okay, but you set it to image. Say okay. Alright. So let's open, we are not in the correct place. Reference, IC16, like that. Let's say find stars, and close that, and open also this one. Now, yeah. So we're going to do the first, delete this, and then we're going to say H, and we're going to take this one and replace all. We're going to take this one and replace with a comma. We're going to take this one, not this one, this one, and replace it with nothing, and say save as, and just remove that reg. Yep, now we got that. So we're going to go in here and say it's IC16/V, And we also have the coordinates, so we should be able to rock. Let's try to rock and say IPython find stars pipeline. And now it says that it can only find 3 stars. That's not very enjoyable, and even with 3 pixels, that's not very funny. But let's check it for 1 second. So we have the V1, let's say fits coordinate. Oh yeah, one thing you can do, and I would recommend you do that, is that you say V2, save and run it again. Because as you, what? No, we didn't run it on V2, sorry. But if you had V2, you would run it on that as well, and then you would see where are the most stars found. And obviously where you have found the most stars, that it is more probable to find the correct stars. Now it might be that I have saved this in a wrong way, something like that, but it should be okay. We have used I think it was DS9. Yeah, it was the V1. We could have used the V2 instead, but I don't think that would have done a huge difference. And perhaps we just don't have that many stars here. But in any case, let's try to check it out. So we have image 18. That is 670 and 97. This number here. And we're going to compare that with S75. S75, it's something around here. 670 and 917. Let's see. 670 and 970. You can see that's pretty okay. So what this gives you here is where you have found stars in the V for this part here. And given that we have only found 29 stars, it is probably okay that we only have 3 stars. Now obviously again you would have run this script again for your V2 and then always choose the stars where the number with most stars. And then what you do is you take out, let's just put them in, let's show you. So image 18, we call that S75. 21, we call that S87. And 23, we call that S95. And then we do this, like this, and like this, and like this. Alright, and then we save it. I'm going to do all of this again for all of the other files, and then I'm going to get back to you. It's basically the same thing that I've done, so I'm not going to show you the same thing 3 times in a row, and then we're just going to do this again and again, and then I'm going to show you why I did this and what the advantage is. Alright, so see you in a bit.